Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. Again, just to get people up to speed because there have been some changes lately, Handmade Hero now has a Discord server you can go to use for chat. It's a lot better than the Twitch chat, and we do take questions from there. There's a Pound Live channel that I read during the Q&A. And there's also other stuff on there in case you're interested. There's a bunch of people chatting on there. It's been pretty good, so I'd highly recommend checking that out. All you have to do is just click this button, the Discord button there, and it will bring you to this page, which allows you to join. That's about all you have to do, and then you are off and running. Now, if you are using the watch page, well, we've got you covered there as well. There's that Discord button right there, and that should do it. Looks like we need to update this page again because it looks like it's having trouble. I think, I hate to say it, but I want to say Twitch sent out a notice that they changed their API. So I think I'm going to have to go update our server code because I think they probably changed it. I don't actually know, but I think they did, so we're probably going to have to fix that. I'm not looking forward to it, but point being, if you're using the watch page, there's a Discord on here as well. Most people don't use the watch page, obviously. They just use the episode guide or they go to Twitch. Well, I mean, they use the watch page to get the episode guide, but they don't necessarily use this thing because, you know, it's all it is just a Twitch bubble. But anyway, maybe we'll change this to just click on the button. I don't know, and then it'll go to Twitch or something like this. I'm not sure, but I'll have to update that because I think Twitch changed their API and probably broke our code, but we'll see. Anyway, moving on. Now that we've got that out of the way, and you have two options to push a button that says Discord and go to the Handmade Hero Discord. Actually the Molly Rocket Discord, but obviously that covers Handmade Hero. We will get down to programming, which, if you remember correctly, we had just finished doing a bunch of sort of optimization work on our graphics pipeline. Just light stuff to get us running fairly efficiently without a lot of fuss. It was surprising how much of an improvement we got by being a little bit careful with how we did our multi-sample resolves. And then we also improved the speed of our transmission for transmitting dynamic vertices down in the case of things like ground cover, where we have a lot of them. And what you can see now is when we actually look at the profile, we're actually doing really well. We're running at about 120 frames a second, not quite, which is quite well. Our target is only 60, so we're like well in advance of that now. And that's good because if you look at what we've got to work with in terms of 3D stuff, how we're going to be starting to stress this pipeline more, we're going to have to move into the land of lighting now, and lighting is going to cost us. So that's really why I wanted to do this. I wanted to make sure we had a pretty good graphics submission pipeline at first, and I think we've got that pretty well taken care of. So what I want to do today is start to actually send down lighting information for these probes. You can see the purple color is there's little cubes. Those cubes are everywhere that there is a light probe placed currently, and as you can see right now, there's 2 light probes per tile. We don't actually know if that's what we're going to do in the final game. It's just sort of an approximation, and it's just a first guess of like how we might want to do it. But that's how we're doing it at the moment. And so what we want to do now is figure out how we're going to actually query these light probes in the shader. So what you can see right now is lighting is effectively turned off. It's turned off because we have not implemented anything that samples these light probes, and we have not actually produced working code on the other side for computing the lighting in the light probes either. So we now have to work on both of those things and have them meet in the middle. What I want to do first is I want to get the light sampling working without actually doing any light computation. The reason for that is I'd like to take light computation, which is going to be much harder to optimize, out of the equation first, because it's the slower of the two things, and it's the one that we probably want to do on the CPU right now to avoid stressing the GPU too much on lower end machines. Obviously on RTX machines, we could just dump all the ray tracing directly to the card and call it a day. But for our purposes here, we probably want to do CPU tracing for most low-end platforms and non-RTX cards and so on. And so what I'd like to do now is say, let's take that out of the equation. Let's pretend we've actually got lighting already computed. And so what I want to do is first spam out lighting that we just like pre-specify. So it's not going to be dynamically computed. I'm just going to hard code some answer to the lighting question into the game that we run every frame that just dumps some fake lighting out into these lighting probes. We are then going to sample that lighting in the pixel shader and see how slow it is to sample lighting that doesn't really cost anything for us to produce. That will give us an estimate of how much work we're going to have to do lighting this way in the final analysis, right? So basically, when we actually ship the game, that is how much it will cost in the shaders to actually run our lighting scheme. And this is important to me because I need some way of knowing how expensive this lighting actually is. And then we can trim down that expense before actually producing the code that outputs lighting to this format. That to me seems like a saner idea, because if we find that it's too expensive to sample lighting as a voxel grid of probes, we probably want to change that scheme first before outputting, before actually spending time working on an algorithm that outputs it, right? So that's what we're going to do now, is get that performance question answered. And that way we won't really have to worry as much going into the next stage of things, because we'll already have the answer that the format that we've chosen will work for our runtime. So that's what we're going to do now. Okay. So in order to do this, we're going to need several different things. And to start with today, the thing that I'm going to focus on is spamming out some prefab lighting somehow that the graphics can actually see it. And we need two things for that. The first thing that we need for that is a way to produce some kind of lighting that can actually tell us that we're sampling it correctly. And then it's not going to look like real lighting, right? Because that wouldn't help, because real lighting is very subtle. And we wouldn't be able to see subtle bugs. We'd know if we had something totally wrong, like the whole screen just comes out black or too bright or something weird. So we'd have some idea if it was working, but we wouldn't really know if we were getting it correct. So what I'd rather do, what I want to do here, is I want to produce something that has some clear answers to it, basically structured art, so I know whether or not we're getting an accurate or an inaccurate lighting sample coming out. And so what I'd like to do is say, look, we know we're putting in 2 lighting probes per tile. What if we did something like each lighting probe had a specific color, top, bottom, left, right, forward, back, and we picked different of those colors for each lighting probe, bright colors. So when somebody hops onto a square, we can look at the 2 probes, say what is the color that we're actually seeing there for each of those probes, and then when we sample the lighting, we can figure out, are we seeing the lighting correctly correspond? Like, as we get further up to the top of the sprite, are we properly sampling the lighting from like the front face of the top lighting probe, which maybe is bright red, and when we get down to the bottom of the sprite, are we maybe sampling the correct lighting from the front face of the bottom probe, which maybe is bright blue, right? And that can help us sort of, see whether our lighting samples are producing blends that make sense much more easily than we can if we literally just said, let's put some real lighting in there, where it's like, I don't know, looks kind of right, I guess. It's very easy to have subtle bugs in lighting. We've already had them. We know we'll have them again, so try to eliminate the cases where that would happen. And so what we need to do is start down that road. So the first thing I want to do is say, let's go ahead and try to make a way of rendering these light probes maybe that produces answers that we can visualize. So let me just give you some perspective on that. If I go into Handmade Hero and I look at where those light probes are being rendered currently, they're being rendered as that sort of purple thing, right? If I go into the entity output, that's where this is happening. I'm going to do a search for the lighting probe output. You can see here where we do show probes, this right here. And that's controlled, I believe, by a constant in here, right? Yeah, you can see that lighting show probes right there, right? And so right now we're saying show probes is true, so we're rendering these push cubes. We're giving them this purple color. I'm going to change that now, again, to just 1111. And so what we're going to see now is pure white probes, right? As you can see there. Now what I want to do, I want them to be pure white. Why do I want them to be pure white? Because I want them to actually sample the lighting now. And so what I can do is, since they're being pushed down in here, I believe lighting is still enabled for most of these things. I guess I don't actually know that. Let me see how that is actually working here. So if we look at push cube, in here you can see emission and Z bias are set to 0. The UV layout stuff is in here. It looks like lighting enabled is just it's just plain global to the render group. So I believe that those will just get lit if we were lighting, right? So they will flow through the lighting pipeline. So what that means is now I am outputting a purely reflective cube to the lighting, and I'm looking to see what. Oops, why do I have two of these? I don't know. And I'm looking to see what I actually get when I run. So I'm going to turn on lighting for these, and then we're going to work on getting those to show what's actually being, what we're actually sampling in that area. Then I'm going to feed in lighting that is prefab specific colors at each of these and verify that they get sampled exactly right. So that's my first test, is if I place a white cube directly on the probe, what do I see as the incoming light at each of these faces? And it should be exactly what I said the incoming light is when I sent the probe down, because I am literally reflecting the light exactly. It is a pure white cube with a normal facing directly in the direction of the incoming light that's measured at that light probe. We should have no alteration of it whatsoever, right? There's no cosine fall off. There's no displacement. There's no blending. It should be 100% correct. So now what we have to do is actually start sending down this lighting information. And so when we think about that, we need to send down, if we look at what our lighting information actually is, if we take a look at what we're sending down, you can see here that we have this notion of lighting textures, and you can see here we have all this light data, and it's basically like a bunch of information that has to do with points that we were sampling. This is all wrong now, right? Because we switched to doing a lighting probe-based solution, and so we don't actually want this. It's not actually the information we would need to do our light probe data. And so if we actually look at what information we will need, it looks a lot more like something like this. Right? Because what we actually want here is to say, look, we've got lighting probes, and each lighting probe is going to encode probably in some compressed format. And right now we could certainly do it this way and basically say, look, we'll pass it down as float to begin with, but later on we're going to switch it to more encoding. Yeah, I could say this. But what we know is, fundamentally speaking, we are going to pass down a series of light probes. Those light probes are going to have, because until we actually, like, you know, adjust this for performance or any of the things that we might want, these light probes are going to have effectively 6 incoming light directions, one for each face of the cube, and each of those 6 light directions is going to store some RGB incoming light value. Now, 3 floats encodes how much red, how much green, how much blue light is coming in across that face. But what you have to remember is that's super piggy. We don't really want that. We could compress that down quite a bit more. We don't need a full 32-bit value per gun. all we really would need is like, you know, an RGB, an 8-bit RGB for how much light was coming in on R, G, and B as a percentage, and then one emission value that's like how strong the light is. And that would allow us probably a lot more flexibility than if we just did 3 U8s, because then we have an extra sort of power for like really bright lights or something. But it doesn't use up the huge... So it's basically an HDR encoding, right? It wouldn't be the ridiculous amount of wasted space of literally a full floating point value per color channel, which I know we don't need. That's way more specificity than we could possibly need for our lighting, I think. Our lighting just isn't that, you know, precise, right? So I don't think we need that, but we do need something like this. And so we know that we would have like... I believe it's irradiance is the correct term in this case, which is basically like how much is coming in. It's how much is received by that surface. Now, it's a little bit cheaty to use the actual term irradiance because we're not measuring this in any particular units, but actually we could, right? So I'm okay calling this light probe irradiance because actually the code that is on either side of it could be upgraded eventually to be physically accurate and use an actual measure of irradiance. So really, we are sort of talking about irradiance. We're talking about a value that's related to irradiance, but maybe we're a little too sloppy when we do our computations to really put the certified stamp of flux on this thing, flux per unit area. But that's basically what it is, and we could make it be that eventually if we tightened up the code on either side, right? So I'm okay with calling it that. If we store our light probe irradiance, what we would do is say, look, the maximum number of light probes that we possibly can have go in here. That's how many we get, right? The light data width would go in here. I'm going to change this to call it something else. I don't even know what like chunk count and some of these things actually are here. So we're going to have to start pulling out some of the old code and actually having it be a little bit more specific here. But point being, light probe irradiance is what we need to send down for each probe. And then we need some lookup structure that gets us to these probes faster. And what we need there is we're going to need a voxel that has an actual lookup in it. Now, I don't think we want more than 65,000 probes active at a time, so I believe this voxel would only really be storing 16 bits worth of data. If we had to actually simulate 65,000 light probes, I don't really think that we're going to be able to do that, not on today's machines and with what we're working on. Maybe on an RTX card, that's fine, but I think we want to target things that may be a little bit further back. Other than that, I'm not sure that by the time Handmade Hero ships, even if it takes us 2-3 more years to do it, I'm not sure everyone's going to have such a beef daddy platform. You know, maybe they do, maybe they don't. But I don't want to make that bet. I just don't know what's going to happen there. I don't have a crystal ball, right? So I don't want to say that we're going to have, like, you know, 16 million light probes active at the same time. I don't think that's like very likely. So probably 65,000 is a much more reasonable upper bound for the kind of thing that we're targeting here. So I would say more important thing to do, minimize that voxel footprint, because that's a lot of memory. Voxels are 3-dimensional. They grow quickly. We really don't want to spam out something too much there. And so if we take a look at speed calc and we just say, look, let's try to define a voxel of a reasonable dimension here. Maybe we say 256 by 256 by 256 times 2. How big would that be? So if we literally had a 256 by 256 by 256 voxel, it's only 32 megabytes, which is pretty good. We could also probably tone that down quite a bit. That's probably overkill for what we need if you think about what's going on. I mean, if we flip back to what we're looking at on the screen here, I mean, come on, do we really need to be that specific? You can see even when we zoom out quite a bit, I mean, you tell me how many of those light probes are on the screen right now. It's not that many. So 2d6 I think is overkill when we're looking at how many are across, how many are up and down. Honestly, 64 by 64 would probably be sufficient. I'm going to go a little higher. I'm going to say 128 by 128. But I'm thinking that this is totally sufficient. That's a 4 meg download. Not too bad per frame, even if we aren't updating it judiciously. 128 by 128 by 128 screen aligned voxel seems like it would be fine with me. That's what I would think. And so what I'd like to do is maybe look at that as sort of more where we're going, right? So 128 by 128 voxel, we'll try to center it around where the viewer is looking. That should give us enough granularity. Certainly in Z, I think it's enough. In X and Y, it should also be enough. But we can see we can always adjust it later. But that, I think, is a more reasonable bound. 64, 64, 64, maybe a little bit too tight. So I don't know, or loose, I guess I should say. Too coarse. Probably that's the right way to say it. So I don't know that we want to go that far, but, you know. So I'm going to go ahead and say light voxel dim. That's going to be 28. We can drop to 64 and see maybe that's fine. We want the lowest we can get away with. And so here we want to say light index voxel. And that's going to be a light voxel dim. Here. I'm going to call it cube for now. And that may be a mistake. I don't know. But I'm going to call it a cube for now. And we're not going to subdivide our dimensions differently. We're just going to put it as a cube, just to keep things simple, and not bias the lighting in any particular direction. So we're just going to leave it that way. So we're going to have a light index voxel. The indices will look up into here. The light data width, therefore, we kind of know what it is. It's going to be 65536 is going to be the maximum. So I'm going to say max light probe count goes in here. And that's just going to be this. And this light chunk count, I don't really know who's using that right now, but we're going to probably find out pretty soon, because I'm probably going to get rid of it. So if we actually look at how much memory is taken up by that light probe irradiance, that's going to be 6 times 65536 as the base number, which, as you can see, is totally reasonably sized. Base number, nothing to particularly worry about, but it's going to get multiplied by 3 times 4, because it's V3 right now. That gets up to 4 megs. I'm not too worried about that, again, because that will shrink, I think, by a factor of 3. We'll be looking more like that. So our total download bandwidth for all of the lighting, only around 6 megabytes a frame, if I'm doing that math right. I'm not sure that I am, but again, nothing really to get too concerned about on the kinds of platforms that can run real-time lighting anyway. So I think real-time lighting kept in those bounds, probably fine. Again, don't quote me on that, because if we then run it and it totally sucks, you're going to come back and say, well, you said it was totally fine. I'm just saying I think it will be totally fine, but it might not. And at that point, we'll have to adjust. So now if we start to compile, I don't know if we've if-def'd all that stuff out. We may or may not have. You can see it here. Okay, so here you can see the one place we're actually still using it. That's in the transfer. We want to basically have this push lighting working the way that it is working. We want that. So when we actually go through and do our push lighting, we do actually want to say here in our transfer, when we push this render element on, we do want to say here is the light data that we want to submit. So we do actually want that coming down the pipeline. Now, one of the things that we probably want to start thinking about, though, is that, again, this is a little bit ugly because it's a push-forward scheme. We don't really want it to be pushed forward in this way. The reason we don't want it to be pushed forward is because, remember, we're now trying to actually do a reasonable job with our graphics output. We don't really want to be copying this memory around all the time. So probably what we would rather do is have this buffer be something that is submitted to the graphics card at least somewhat plausibly. So if we go back to the way our platform, if we go back to the way our platform output for graphics is working, what we can see when we look at the, actually, is this in the, I think this is actually in the renderer now, though, isn't it? I think it actually is. Yeah. So if we take a look at where this stuff is actually going to get output, right? You can see that when we do our game render, right, here is the actual primary structure that we use to send everything down. And what you can see is we actually have a specific thing that we give to the game, and we say this is where the vertices go. And then we say this is where the indices go. Now, why do we do it that way? Well, the reason we do it that way is because we actually want the graphics card specifically, or rather I should say the graphics driver, to tell us what memory to put these things in. The reason we want the graphics card to tell us where to put them is the graphics card may be able to allocate those things in such a way as to eliminate extra work done by the CPU to put them in a place where the graphics card can actually get them. And so we don't typically want to just surprise the graphics driver and say, hey, graphics driver, guess what? Here's a place that has all the lighting data in it. It is usually going to say to us, oh, I really wish you'd asked me first because I would have told you to put it over here, not over there, right? And so probably what we want to do is change this render entry lighting transfer a bit and say, let's do a little more work there. Let's be a little bit more specific and say, all right, let's put this in here where we say max light probe count. And then we say max light probe, light probe count. And in here, let's put the actual lighting data where it belongs, unlike what we were doing before. So instead of having this render entry lighting transfer operation or any of that stuff, we're just going to nuke this lighting textures. That's going to go away. What we're instead going to do is just output it directly where it belongs. So these things will go in here, and this information will actually probably be something that we just specify in this, right? So maybe here we say light voxel dim, like that, right? So light voxel dim we get rid of. That's not going to be a thing. Max light, that's not going to thing. They'll actually come through in here as runtime values, and the lighting textures will just disappear. It's not going to be used anymore, and we'll output our stuff directly into something that we actually want, like this. And that will look like that. And you can sort of see here, so we've got light voxel dim by light voxel dim by light voxel dim. Here we have light... probably should make this actually look right. So here you can just see me notating, like, this is what these are going to be. So it's basically like whatever the max light probe count is by 6, right? That goes in here. And the light index voxel is just going to be the, 3 times that dimension, right? And so later we can make those settings if we want to. Right now I'm just going to hard code them into the render and say this is just what you get. And we can make those be settings in the future if we want to try and make it be more flexible. But I'm not particularly motivated to do that because I don't really see any point to it. The lighting fidelity will just be what the lighting fidelity is. And that'll be the end of it, right? So pretty straightforward. Okay, so if I compile this now, we should get some compilers because I've gotten rid of the lighting submission stage altogether, right? So if we take a look in here and we see push lighting, like, I don't even want to talk about push lighting anymore. Like, I don't really want that to be something that you ever even do, because again, push lighting it's just not gonna work the same way. So we're gonna kind of get rid of that notion altogether. That's not how lighting will work in our system, right? So now what we need to do is kind of, oops. I guess we need to get rid of that a little bit more specifically there. So here where we do like output lighting points, right? That is no longer going to work this way. Instead, what that's going to do is it's going to output directly into the function in question. And so when you do output lighting points and output lighting textures, whatever, I'm going to go ahead and say, like, we're going to nuke some of these things completely. So here where we do this, where we say output lighting textures, I'm just going to do that, right? That's the only one we're actually going to have here. And then this code will be adjusted to write into the render group directly. That's what we want to do. And so here when we come back and we look at the lighting textures and we do this push lighting here, I don't really want to do any of this stuff the way that it's being done at all. So we're not going to do it this way, right? That's not what's going to happen. So when we do a push lighting there, you can see, this was actually using that old code I just deleted. We don't want to do that anymore. We're just going to assume that the lighting gets written into the render buffer, and the people who are using the lighting use the lighting, and that's it, right? There's nothing else to it. All right, so let's go ahead and delete this for the lighting textures part of things. I don't think we actually need that on here at all. So I'm going to go ahead and keep hunting for compile errors and just try to clean this up a little bit. So now when we see, okay, are we going to do update lighting? We are going to call our lighting test here that actually does the lighting. And then you can see us doing some stuff here where we're doing like, you know, do we want to show the lighting or not and output the lighting points and whatever. We can't really do this anymore, so I'm going to delete this for now. We may re-enable it later if we actually have some way of debugging the lighting separately that we want to use. We can always re-enable that, but for right now I just want to focus on this. If update lighting is enabled, then we're going to run this lighting test here. That's going to do it like that. And then if we want to actually put the lighting out to the graphics card, what we're going to do is we are going to, I'm not sure what that's actually trying to say there, so that's probably not correct anymore, but we'll leave the if in place anyway. When we do output lighting textures, that's actually a real thing still. We just don't pass it anything, right? So it's actually going to output the lighting textures into that render group. It will be doing that. It's just not going to do it this way, right? It's just not going to do it by a texture call. All right. So now when we run, I don't know. We may have to go clean up some other stuff. We may get a crash, or you can kind of see. So when we're actually doing stuff, if we don't call that lighting push, and I'll probably switch now that we're going to kind of get into some more serious stuff here. I'll probably switch to a debug build so we can inspect our code better as we work through like what happens when we pull that stuff out. But what I'd like to do now is when we actually do our lighting test here, I want to make the lighting test call just be something that it gets past the light probe information that we actually need. And it does it kind of all in one call. Now, if I bounce back to where we were talking about the lighting, I don't really care about most of this crap, to be honest, this lighting point recurse. I'm going to leave it in there in case we need it later, but honestly, a lot of this stuff should just go. But all right, so coming back here, and you see what happens during the lighting test. You can see, first of all, we do some nonsense with sampling and stuff. This all has to get fixed when we actually do lighting because we built our sampling table. Now we can actually use it. But forget about that stuff for now. When we actually come through here and we build our spatial partition, what you'll notice is we expected to kind of have something here that recorded which light boxes were actually involved, right? And you can see here, we actually do grab that out of the render group. Here's the light boxes here. But what we saw before was that I think without calling that push lighting call, we didn't set some of the state that we actually needed. So we need that state to be set here. And so this should crash right at that point. Hopefully. Yeah, you can see it here. And what you can see is we're trying to get this root box set up. The reason we can't get the root box set up is because when you called that push lighting call initially, what it did is it output a box that we use for our root lighting box, right? And you can see that happening here where we sort of said, look, here's the root box, it's box 0. And so we kind of we're expecting to always have that be built into the system, right? But it wasn't properly built into the system because there was no box 0 reserved. So, like right here where we do this, if nobody outputted any lighting at all, right, or something like that, then there would be literally no boxes. So when we ask for that root box, we would actually get nothing. There would have been nothing there, right? So we definitely have a bunch of work we're going to have to do here to sort of make this stuff work a little more cleanly. But this is work we want to do anyway because our lighting was not really getting sent down in a particularly good fashion before anyway, right? So let's take a look at how that actually worked out. If I go, I mean, one thing you could ask is why is that even happening to begin with? To be honest, when we look at because rootbox is not even 0, so I'm not sure. That may just be because we're not setting that array or something. Let's take a look at what happens there. I'm going to take a breakpoint into lighting test. Just see what happens there. So here we are in lighting test. Obviously, we don't care about this part. This is actually about the lighting sample. So here you can see us starting up, looking at what we're getting. And you can see here, this is the render group that we're asked to do the lighting on. And you can see that it actually has no light boxes allocated whatsoever, right? There's nothing in that light box array. And so that's our first problem, because that's what we actually need to do the lighting on. So the person responsible for actually allocating those light boxes didn't actually allocate the light boxes, right? That's the problem. And so, you know, that push lighting call was originally doing it, so we kind of do need something that's going to allocate light boxes, but my question is, why are we doing that way anyway? The light boxes really should just be a static thing that's inside the lighting to begin with, and you don't transfer it, right? So what we would rather do, I think, is when we actually do an init lighting, you do the light boxes here, right? This is where we actually want that to happen. And we want that to happen in such a way as to always be correct. Right? So when we look at what's actually happening when we allocate the light boxes, what we want to do is figure out, okay, we're going to start pushing light boxes onto this system. What we want to do is actually have those just be allocated and reused, right? I mean, that's really what we would like to do. So I think they should stay inside the lighting system. And then instead of calling something like push lighting, what we should actually do is call something like, here is the light target, right? Yeah. So I think what we want to do is more like this. When we go into update and render world, when we create the render group that we're going to be using for our actual assets here, what I want to do is say, look, that render group that you're going to feed all this stuff through, let's go ahead and set the lighting. So we want to say something like this. Let's set the lighting output equal to whatever our lighting box array is, right? And then that's where we'll output that information. Now, again, just trying to think about what that actually means, we have sort of two separate sets of information here. So again, I want to kind of try to think this through a little bit better than we were thinking it through before. We want to have in our lighting two different things, probably. We want both lighting probe information and we want light box information. And the light probe information kind of needs to stay over time as well, right? So if something's a light probe, we want to store the light probe data, and we want to update that light probe data. And so probably what we want to do here is actually, because we want this to be more efficient long term, we probably want to sort of contemplate a few more complicated things happening. So I think we may want to do this. Something like this, or like that. So we kind of mark where we begin the lighting computation, and then I think we mark where we end the lighting computation, right? And so when we get down to the place where we actually do the lighting test in here, I think we would do end lighting computation. And maybe what we say here is just like, did you actually want to do lighting, or did you just want to like throw away what was asked of you, and so on, right? And so I think we probably want to do that like this, and we want to get rid of all of this. And then maybe there is a thing here which says like, output lighting textures in the case where we want to show it or not. But I think what I'd rather do is just weld that in here. So we'd say like update the lighting computation this way, and then maybe this flag we just get rid of for now. So I basically just look for, if I go look in the world mode, We've got this weird show lighting thing that's on here, so I'm just going to say like that actually goes away. You don't get to do that. And then this output lighting texture is part of things. When we go look at that actual call, this output lighting textures is actually not going to be in here at all. That's actually just part of the sort of finishing of the lighting routine, and it's just assumed that that will happen. So the test lighting call, this right here, this test lighting, that's actually going to be where that actually happens if we do it at all there, which I don't know that we necessarily will. But we're going to need to do that at some point. And so that means that this is actually like the end lighting computation call. You pass in here like the lighting solution that you wanted to use. You pass the render group. You pass the high priority queue, and then you pass a bool, which is like, lighting enabled. That's whether or not we're actually going to do the lighting or not. And then we've got a call that brackets it, and that's the begin, right? And that's this. And that's responsible for setting up anything that actually needs to happen with respect to the lighting, right? So again, just working this through, trying to clean it up a little bit. Obviously, our renderer keeps improving over time, and it keeps converging towards something that's more like a real renderer, which is exactly what we want. But that requires sort of these phases of like, okay, let's clean this up. Let's make, like, now that we see what it looks like, let's make this stuff work a little better. And I also, of course, am eyeing this as, as I'm doing it, I'm also trying to kind of imagine, well, I don't want this to be too far away from a hardware solution, so that if someone does want to implement an RTX version of this thing that does all the ray tracing really quickly on the GPU side of thing, and maybe like improves the quality too, right? Because if you can get more speed out of it by like using an RTX card or something like that, then what you could do is crank up the number of rays per probe and crank down the smoothing. That gives you more responsive lighting, but with the same quality, right? So basically what you could do there with our lighting, certainly as machines get better and as ray tracing becomes more prevalent, assuming that is what happens, we'll also kind of want to be in a position where we can choose to have a driver that actually does this on the graphics card over time. We can transfer that work over there as those parts become more powerful and have special purpose things just for doing it. So there's how we would do sort of that setup. So let's keep going. We've got our lighting solution here, and what we need to do is do that initial setup. And so what we want to do is take our lighting solution, and probably we want to allocate space for the lighting boxes right in here for now. And again, this stuff is going to improve over time. But we kind of want to make sure that it at least is running nominally so we don't get too far from a working program as we focus on each individual part. So this is not really relevant to us right now since the light boxes are occluders, and we don't really care about occluders right now, right? But we kind of need to keep them in the mix because we are going to have to work on them eventually. So we're going to push an array on here. We're going to have some kind of a maximum light box count that we want to enforce. That will go in here, and so on. Now, the thing is, we may actually, now I'm thinking about that, again, we may want to do the same thing we did before. If I go back to that renderer platform information like we're doing here, one could argue that the light boxes actually should go in here because, again, they might want to go down to the graphics card. So I may want to do this, something like this. And we've got this notion of a light box. That thing is going to change. We don't. It's really just an occluder now. It's just a box-shaped occluder, right? And so I think what we want to do here is stop talking about any of this stuff. Light boxes really. I don't know where they went. Lighting box. Sorry. So if we look at this lighting box, right, this is just not something we care about anymore, really, in terms of the emission texture index stuff, like that sort of stuff. This is just not relevant anymore because lighting boxes are just occluders now. That's all they do. And so we're going to kind of keep it this way. But that's really what those are going to become. They are no longer things that we actually use to specifically like remove. I'm sorry, they're no longer things that we use to collect light as well as block it. They're things we use strictly for blocking light. So they're only occluders now, and the things that actually capture the light are the light irradiance probes that are placed throughout the environment. Okay. So I think that's more what we actually want to do. And so when we're outputting lighting, it's going to go more into something like this. And so let's move towards that a little bit more as we go. When we go to the renderer itself and we look at what's happening in there, what you can see is that our render group, if we just take a look at how this is being output here. If we look at our render group, these are the things that we want to output there. And normally we get them through game render commands. You can see that the lighting had that stuff kind of as a separate sideband. And so what we really want to do is now get rid of that, right? We want to get rid of the light boxes. We want to get rid of the light box count. All we really want is something like this. Light point index not necessary. So we pretty much want to remove all of those things if we can, right? I also don't know to what extent we need light bounds in there, but we'll talk about that later. So I'm going to nuke all of that. Light box count is gone. Light boxes are gone. And light point index is gone. We're just going to talk about light enabled now. And then when I compile, I should have a bunch of problems because the code that was still using that stuff is going to be in a bit of a bind, right? So here we go. We want to, take a look at this stuff where the lighting boxes work with the entity cache. Over time, what we may want to do is only write out occluders when they come into and out of the active set, right? That's a pretty easy thing for us to do. So we probably want to keep that in here. Probably. I don't actually know. I'm going to say at the moment, since everything's dynamic, we're not probably going to want to do that because it's just really just a position anyway, and that position can change every frame to a certain extent. So I don't know how much we really want to compress that. So I'm probably going to get rid of that for now. But anyway, so what we're going to look at here is we're going to still look at the lighting enable call in the group because some things don't want lighting and other things do. When we actually do a push cube, we do need to put an occluder on there because these are occlusion cubes. They block light that comes through. But we're not going to do it this way. The commands is where we'll get this stuff now. So what we'll do here is we'll look at the commands, light occluder count, and we'll see if that's less than the maximum we're allowed to do, right? Assuming it is, we'll still output the light box the same way we used to. And that's to say that we will grab out of the commands our light boxes, in this case, or I should say light occluders. And we will increment our light occluder count to account for the one that we actually used. We'll then write it out the same way we used to, but of course the texture information now is, well, actually I guess we do want that. We need to sort of fix this stuff because what we actually want to do here is write the average value for this texture in here. We'll have to see what we want to do there. I don't really know what we want to do there. That's a really good question. If we were super squinky, we'd probably actually keep backing source of the textures, at least at a low resolution, and actually sample them when we were doing our lighting. But man, that's getting a little bit far afield. On the GPU, that is what we would do, but you know. So moving on from there, we take a look here and we say if it's enabled, we're going to write out that box. Otherwise, there's really not much else to do here for lighting. You can see us going through there. And we then pretty much just go through and output the cube as quads as necessary. You can see that happening here. We should probably optimize that path now that we have optimized quad output, but hey, that's a story for another day. If we go in here and we push, look at what the push quad has on it, You can see that we no longer really do anything with lighting information in here as far as I can tell. That is by design because now that shouldn't really be involved in here. So that's great. That all looks good. And so now really all we need to do is make sure that we're pushing lighting probes on here in some way, because at the moment we actually aren't doing any of that at all. So now if we compile, what we should get is during lighting passes, when lighting is enabled, we should actually get basically a memory access error, because people are going to try and write to an array we haven't initialized, which is this light occluders here. We're going to do that in a second. Let's finish up our compile errors first. You can see I forgot to change that to commands. Remember, it's not coming out of the group anymore, so that was a bit of a screw up. I think we had another compiler in there, though. Let's take a look at what it was. Here's us at when we actually go to do our end lighting computation. You can see us trying to work with this stuff, our box count and our boxes. What we want to do there is try to make this thing work out a little bit better. Like I said, not using the group. That shouldn't be too hard, because when we hit end lighting computation here, all we should really have to do is get this stuff out of the game commands themselves, right? So I think all we really need is something like that. I don't think we really need anything more fancy, right? That should do it. It's light occluder count, of course. And then when we actually go to access the light boxes themselves, it's going to be the same thing. But other than that, I think we're good. And again, that's just memory that we're going to be expecting to have provided to us by the platform layer, because the graphics card may be the thing that wants to do it itself. Now, lighting is not actually the right thing here. I think it's world mode lighting, if I remember correctly. Test lighting, sorry. But other than that, it's exactly what we had called there. Nothing particularly weird. And now we have what I think is a more sane pipeline for that stuff to flow through. And it's shortly going to become something that we don't really call test lighting anymore. It's actually going to be fairly reasonable lighting. Now we get to the part where I said we should get a crash here, because we're going to try to render. We're going to try to write to an array that doesn't have anything in it, or in this case, read from an array that doesn't have anything in it, because the solution boxes themselves don't actually have anything there. So if we look at what that pointer is, that pointer should be 0, because it came from something that was uninitialized, just like it was before. And so we expected that to happen, and it did. Here is that box's pointer is 0. So what I want to do now is bounce back to the platform layer where this is actually getting initialized. And actually, I guess that would be in Win32 Handmade OpenGL, or is it actually in Handmade or OpenGL? I'm not sure. Let's take a look at that. I don't actually know. So when we actually allocate those pieces of memory, right, we're looking at what we're trying to do here is when we go to start our process, we allocate memory where this stuff gets put. And so if you look, let's just go ahead and search for it, because I'm not sure where it is in here actually. If you take a look at that renderer layout, we've got things like the vertex array, and we're trying to map those, right? So let's take a look at where we put those. You can see we've got here, like, we're creating these buffers, right? That stuff here. What we want to do eventually probably is do these things exactly analogously. So that we can transfer them quickly. We want to have the driver be aware of them and tell us where we want to put this stuff. But for right now, we're doing basically everything ourselves with the lighting, and we're not contemplating doing it on the card at all. So what we want to do is just allocate this as normal. So this is inside the OpenGL init call. Now remember, we also want to free these things when we go to change the settings. I guess, well, actually, no, I guess we don't do those. We don't actually free those. We just keep those the same. And so what we should be able to do here is just say, all right, when we're in OpenGL init and we're creating our initial stuff, we can just allocate those and use them as is, right? So what I'm going to do here is exactly what we did with the other things. I'm going to say that we're going to want the light occluders, and we're going to allocate those. I'm going to say that we want our light probe irradiance, and I'm going to say that we want our light index voxel. And then what I'm going to do is when we actually go to transfer those. When we look at what happens with vertex array, and when you begin a frame, right, and you initialize all this stuff, I'm going to initialize all that stuff here as well. So in here, we're going to allocate this stuff. So places where we actually need some memory for it. And what you can see here is there's pretty much no there's no actual memory getting allocated here that I can see, right? It doesn't actually seem to be doing any allocs, which is kind of a bummer for us, right? Yeah, it doesn't actually do any allocs here, so I need some way of allocating some memory that we're going to use here in the Handmade OpenGL driver. I don't know if we've actually got that anywhere, unfortunately. I would like it if we had some allocation somewhere, but I'm not seeing it. Because remember, I want to keep this fairly isolated. I don't really want to tie this in. So we have all those services in our game normally, but I just don't really want to have the renderer tie into anything that it shouldn't be tying into. And so I'm just trying to figure out if we have anything in here for allocation that isn't GPU side allocation. So far, everything we do here is GPU side allocation. Right? I mean, you just look in, there's tons of allocation going on in here, but it's all stuff we ask the GPU for, right? Nothing in here is not. So I'm interested in that light buffer count variable. What's happening there? Yeah, sadly it just doesn't look like it. So I don't know what we would do there because we haven't ever contemplated needing separate memory here. And that's kind of a bummer. But I guess it can't really be helped because we just decided we didn't want to do that. There's other ways I can do it then. So I guess I'm not that worried about it. I could just not allocate the memory at all. I could say instead what we do is these things are actually just placed directly onto the struct here. And we'll just say, all right, fine. If that's the way you want it, that's the way we'll do it. There's going to be a light index voxel. The light index voxel is going to be just 128 times 128 times 128 or something like that, right? And we'll define that. So that array is just exactly what you would expect. We will then have the light probe irradiance values, and those are just going to be 6 times light probe count or whatever it is, right? So something like that. And that, we'll just say is this. Maybe I'll be a little bit more, I mean, maybe that's too much, right? I don't really know what we want that value to be, so we'll think about that. But these are going to be our OpenGL values here. And then we'll say that light occluder array is something as well. Who knows, right? And then we don't have to contemplate allocating memory. It's just part of the one allocation that we do that stores everything the OpenGL driver needs, right? Pretty straightforward. Okay, so if we then go in here and we say, okay, how are these things going to get distributed? Well, now we know. We've got the light probe irradiance. We've got the light index voxel. We've got the light occluders. And that's the setup, right? It's all good. And so that's really all we would need to do now. And up here, we don't actually need the OpenGL allocations that I was contemplating because they're just part of the array now. So if we actually look at, like, you know, this stuff just doesn't happen. So that's really all we would need to do. And then in here, every time we restart a frame, we want to do the same stuff we were doing before. So if we look at what's happening in the renderer when we initialize that sort of send down, we want to make sure that these things are all initialized properly as well. So if we look at the max light probe count, right, we want to do OpenGL max light probe count. If we look at the light probe count initial value, that should start at 0, certainly. Then we've got the light voxel dim. OpenGL light index voxel dim. Just separating this out a little bit better. Maybe I'll do that, right? So you can see, like, okay, max light probe count. Here's the light probe irradiance. Then we got the voxel dim and the light index voxel, right? So those get set like so. And then finally we have the max light occluder counts, which is going to be, oops. It's going to be that. I don't know why I called it the occluders. I don't normally do that. And so then we have the light occluder count, which will start at 0 for every frame as well, and the light occluders. So that all seems fine to me. And then we just need to actually do this. And create that value with what I said instead of what I did. So those are our OpenGL maxes there, and I need to put those somewhere, right? So if we take a look at where we've got those pound defines in other places, you know, like depth component type is one of the defines. Looks like actually we don't really have any, honestly. So I guess I don't know, but I think probably they should go in here, right? They should be things that are at the top of the OpenGL header, probably, just so they're kind of visible, right? All right, and so then finally, that light index voxel dim is just something I changed the name of it, right? Because I wanted that to be something that was specified with the same name as the member that it actually had. So if I go ahead and look actually in renderer.h, this right here should just be changed. So now I think we're filling all those things out more properly, so we actually have the ability to send down lighting information kind of the new way that we want. So let's go ahead and debug that and find out what we've done wrong there. Looks like no crashes. Doesn't really mean much. That's good. Doesn't really mean much because we're not really doing anything right now. And also, we haven't actually enabled the lighting, so we're going to have to sort of do that and get that contemplated as well. So let's actually try to find out where light enabled was actually happening here. So I'm going to just do a search for that. Oops. Lighting enabled. And what you can see here is we've got a check on it here. We've got an actual enable call here. And that's pretty much it. So what we're looking for is a call to enable lighting. We don't know who's calling that right now or if anyone ever is. And it looks like no one actually is. So what we need to do is actually enable the lighting somewhere. No one's actually ever turning that on. And so what we need to do if we want to start contemplating lighting at all is we're going to have to actually enable it. So in here where we do begin lighting computation, we actually need to enable the lighting on this render group as well, right? And maybe what we should do, the way that render group is working, maybe that should actually be how we enable it. So maybe we want to do something more like this. Oops. I don't know where that lighting bounds actually was being computed. We'll have to take a look and see. It looks like in here you can see light bounds being computed here. So actually it looks more like this stuff wants to occur a little lower down. So once we actually compute where the lighting bounds are going to be, we would do it here. We would say, here's the light bounds, right? And we're going to enable lighting on this group. Now, what I don't like about that is you can see that it's kind of like two calls, but you'd have to make both. That doesn't seem very good to me. And so when we do begin the lighting computation, I think I might want that to sort of be where that happens. So I might want to do something more like this. Oops. That's not what I actually meant to do. I might want to do something more like this, where you say, okay, you say begin lighting computation. That actually happens on here. Maybe in the future these things weld together, but either or, we've got one of our rectangle 3s. That's the light bounce. You pass that here, and that's where it actually occurs. And then in here, we pass the light bounds down like this. We then say that this is the thing that gets whether or not lighting is enabled, not the ending call. So in here, where you're passing that, maybe we actually pass that up here. For now, something like that. Not sure how we actually want to do it, but something like that. Like so. And then this can actually do a thing that says, well, we enable lighting or we don't based on that, right? So then in here, this could actually do the lighting or not based instead on whether or not anyone actually enabled the lighting, right? So if this was passed as false, then it just won't do it. Right? Okay. So we're getting closer. Again, it's getting better. It's not perfect yet, but it's not horrible. And then what we can do is run it and see if that makes any sense to anyone in the lighting code. And we don't really know, right? So now we're actually running slower, and that's a great sign because it means we're actually doing something. If you take a look at the profile, you can see that actually we're spending time in our end lighting computation. And that's what we want, right? We want to actually spend some time in there because we're now pushing down some actual stuff. So that's all good. And now what we want to do is start to actually use these things that we have provided space for, provided a place for them to exist. All right. So what I want to start with is we now have a place where we're outputting the lighting coherently. Every frame, we're actually filling out these things. We're not actually filling out our lighting probes. So we don't actually say anywhere where these lighting probes are actually getting specified. And so what we want to do now is actually put that information into in the lighting system because we know, we do know it, right? And so in here where we do our entity output, so in the entity output call, what you can see is we sort of have, we've got some stuff we maybe need to streamline already. We could think about trying to make this, again, keeping with the idea of trying to make this amenable to a hardware implementation eventually. There are some things we might want to do to make things easier on ourselves, but I'll kind of talk about those in a second. But where we're outputting this stuff right now, we do know when we hit a lighting probe, right? Because you can see right here we have an isLightProbe call that asks exactly that question. And then we push a cube on here to draw it. So we clearly know we could draw a lighting probe. I also don't know what we're doing with this light probe count thing. I guess we're just specifying that somewhere. Oh, in fact, you can see it here. But we really don't need that, right? Because now we can do this. This render group here, we can just output that number, right? So here, instead of light probe count, we can actually just do this. And if, I'm sorry, that will just tell us what the light probe count is directly, right? So if you look at the render commands and what the light probe count was on those, in here you can see when we look at everything that we've done, we actually know what the light probe count is because that's actually something that we now have to track. So we don't actually need to track that separately. That was just something we were playing around with as something we wanted to kind of know off the top of our head. So that's totally fine. If we move, that's good. If we move down here now and we take a look at, oh, you know what? I forgot our draw cover is not happening in line anymore, right? Draw ground cover is now happening sort of as a separate pass that we were timing, right? I think. Yeah. That doesn't really have to happen anymore, right? And so that's probably just sort of a waste. So I probably want to get rid of that too, right? We probably want that to go away, and that probably wants to come up and be re-enabled in line. There was no need for us to do that the way we're doing it. Okay, so anyway, moving on. So when we output this now and we do is light probe, what we really want to do is just send down the actual light probe, right? So we want to do this because that's like a debug feature. But we also want to do a thing where we actually push a light probe onto the light probe stack because we're actually going to want to use those now. Like we want to actually know what's going on. And if we look at our entity, when we look at what's going on here, you can see we're not really storing the light probe information yet, right? And this is where I've sort of gotten to the point where I don't actually know if we want to stream these out, right? This is what I was saying before. The light probe position is something that we do need to stream out because it may move every frame. Like we don't know where the lighting probe positions are actually going to be. But we do need to save like the color of the light probes. And so what will happen, and what I want to just keep an eye on, is we kind of want those things to persist on the graphics card if we ever choose to make them be graphics card related, right? And so what I think we'd find here is that the light probes that we have in the system kind of need to have stable indices, and those stable indices maybe need to go along with a stable backing buffer, right? And so, again, I think we need to be careful how we do this. So when I'm looking at the commands there, right, maybe I was a little bit hasty on just that one thing. Light probe count may just not be a thing, right? What we may actually need to do is take a look at the world itself and look at the way that the caching system works, right? And say, how many entities are cached at any given time, right? So if we look in here, we say max unpacked entity count. And what we do there is we're actually taking, I think, this value and using that in some way, right? Yeah. So what you can see here is we have a max unpacked entity count. And I believe right now our entities are where the light probe data comes from, right? Like we place entities in the world that are our light probes. That's what we're doing. So when we actually create this unpacked entity count here, right, we sort of have a problem where we don't really have a problem, I guess. We have an opportunity to say we could just use the indices that we give to each entity transitorily while it's in the active set as what that lighting information, as where that lighting information goes. There's a few things that I don't know if I like about that. I'm sorry for not being particularly lucid here. It's just a little bit touchy and I'm trying to think it through. I guess what I would say is while occluders probably want to be streamed out every time because they have no state, they're just crap in the world that needs to intersect lights, light probes want to be averaged over time. And in order to average them over time, I need to know from one frame to the next which light probes are which. I can't just have an unorganized collection of light probe information because I won't know who to blend. So, what I would like to do is assign an index to each light probe rather than it being where it came in the order of draw output for this frame, which is not stable, I'd like it to be based on something that from frame to frame is always going to be identical. And I think the best way to do that would be to say every entity, when it gets unpacked, already has to be unpacked in such a way as to have a unique identifier. That identifier will be unique to that entity until it goes out of the active set. And so what I probably should do is when we unpack an entity, give it a spot in the light probe based on that index. Now that's piggy. That's the main problem with it. It's piggy. We don't actually need that many because there aren't that many light probes. The number of light probes is drastically less than the number of entities, right? And so the only thing that's a little bit hairy there is not wanting to have the indices do that. But if we are saying that we're just going to incrementally update the light probes anyway, then I guess maybe the answer is we incrementally update that array by writing into it like a sparse texture anyway, in which case we don't care if big blocks of it aren't used. I'm going to go with this for now because I can't really think of a reason not to. So here is an alternative proposal, and it does seem better. If instead of doing that, we kept a separate list, and that list was just for allocating light probe indexes. So when we unpack an entity, if it's a light probe, we assign it a light probe index. If it is not a light probe, we don't. That would definitely be better, right? Because that would mean that if we said there's only ever 10,000 light probes active at any given time, then even though there can be way more than 10,000 entities in the uncached set, in the cached set, we wouldn't actually need the light probe backing store to be that big. Now, it may be that that extra bookkeeping just isn't worth it because we don't have to, because maybe it's fine to sparsely update that array on the graphics card or with the lighting system and stuff like that, right? But I'm like unconvinced, right? Like I feel like we may want to keep that that set fairly tight. I really think we're going to want that. I guess that's all I can say. So I don't really know. I'm really kind of conflicted about that, and I don't have a particularly good idea about what's going on there. But, you know, if I actually look at what goes on in the world set, and if we look at what's actually going on, you know, you can see here we've got like a use chunk space, add to free list sort of thing. You can see we've got a free list for that, and then in entities we've got a free list for that as well, right? Right here where we unpack our entities, this is where we actually assign those entities to something. Register entity where we're actually going through and like packing and unpacking them, right? Like we say, look, if this is an entity we need, we just call this acquire unpacked slot, right? And that just says, let's grab the entity, the next unused entity out of that slot, right? And I guess we just do at the head end, we cycle them around. So it looks like we don't even really do a free list. We just keep it a compact array. Yeah. So I'm going to go ahead and say we probably just want a free list there. So, all right, it was a tough decision. I'm not sure if I'm making the right one, but I think this is what we want. I think in here what we want to say is, look, there's a certain number of light probes that can be active at any given time. And that's just a limitation of the graphics subsystem, and it's going to tell us what that is, right? Or we're going to, come to some agreement with the graphics system about what that is. And so what we're going to do is we're going to say, okay, in here, we're going to assign some kind of a lighting index set. We're going to say like light probe slots and light probe slot count, something like this, right? And maybe the way we'll do this is just always with a free list. So we might actually say something where this is just initialized to a value, and then this is the set. And then we'll say first free light probe slot, right? So yeah, what I would say is we'll just do it where when we pack stuff up, we basically free a light probe slot, and when we unpack stuff, we'll use a light probe slot. And then the light probes are really not streamed out so much as they're just placed into the system, period, right? And when they're placed into the system, we just set the count to the highest count that's actually been used. And I think that's probably all there is to it, really. I think that's the best I can do. And we are going to have to think kind of hard about how we want those light probe indices to be assigned, because we don't want only things within the view frustum to get a light probe index, but we also don't want everything outside of it to get a light probe index automatically. We want to have a sort of region, a bounded region, which I guess will be our light bounds. And we'll probably want to pack and unpack based on that more so, or assign and unassign based on that. So my assumption is that it's probably going to be something we do on the pass through the entities. We're probably going to assign the light probe indices sort of based on that a little bit more. And we're going to have our work cut out for us here a little bit, because we're also going to have to basically stream light probe updates that have to do with, here's what we want to write out to the updated color values for each of these light probe indices, right? So this is going to be nasty. Like, this is going to be tricky. There's a lot of bookkeeping here, and there's a lot of things that could go wrong. But I think we kind of need to do something like that, because again, we need these things to be stable over time, because if we don't keep them stable over time, then we won't ever be able to do a hardware implementation. And obviously for a ray tracer, you would definitely want a hardware implementation for higher end graphics cards, because they've got silicon sitting around designed specifically for this, right? And probably will do that increasingly more so, right? So all right, let's take a look at how that would work, taking this into account. So what we need to do now is say, in here where we've got the discard set, we kind of want to say in here that you get assigned a light probe index. This value will be meaningless if this thing isn't a light probe, but if it is a light probe, it will get a valid light probe index when it gets unpacked, and it will get it through this. So if we look at how the world assigns things, what it needs to do here is when we actually create the world, so where is that? There it is. In the create world call, we're going to need to do a thing where we say the light probe slots in light probe slot count. These have to be assigned however we wish to assign them, and we need to put an upper bound on how many of them we will ever choose to assign. And in order to do that, we probably need someone to tell us, honestly, how many of these they want. So during create worlds, what we probably want to do here is say, look, you tell us, what's the max light probe count? We then create enough room to store all of that. And then we initialize the free list to just be that. Everything is free, right? There's nothing taken up yet. So what we say there is, all right, we're going to make each of these things free. So we're going to loop over every light probe slot we have. And we're going to say that the light probe in that slot points to like its predecessor, let's say. If we wanted to start by occupying light probe slot 0, what I might say is that 0 should probably be an unused slot. So it should probably be the case that no one can ever fill that slot up, right? So what I would probably say is, you know, light probe slot 0 is going to be stuffed at 0, and we're never going to let that do anything else. We're going to say that the first free light probe slot is going to be 1, so we'll start filling it out there. And then here what we'll say is, well, let's just go to the end, right? And let's say, actually, you know what I could do? Well, no. Let's just go to the end. And let's just say that each time through here, we're going to set it to be equal to whatever the next one is. So it's just a daisy chain. So the first free one is 1, and then 1 says the next free one is 2, and then 2 says the next one, you know, so on and so forth. We then want to get to the end of this and say, look, at the actual end, we get to a point where you don't get any more, right? You've run out of light probe slots to assign, so you know, game over. So I think that's pretty much what we want to do there. And now we can properly assign these as we go. Now, what I don't actually know is, should this live in here or not? Because one of the things that we could contemplate is, since it doesn't actually matter, you know, maybe we want that to be something that's actually external. If we look at what happens here, you can see that fill unpacked entity. If we look, we call out to the game to say, hey, we're going to use one now. And similarly, in here, we kind of, when we're going to pack an entity up, we could have called out there as well. So when we do fill unpacked entity, we could alternatively, if we wanted to, make a call out to external code that maybe keeps the lighting information updated separately, right? So I don't know the answer to that question, but I might say that, you know, just looking at it, it kind of feels like maybe that is what we would want to do, right? And so maybe we just move this over to world mode and say, well, yeah, in that voice. Maybe that stuff goes in here, right? And maybe what actually happens is, you know, when we do this sort of fill here, maybe when we call those things, that's responsive to the world mode. Now, looking at it, the only reason that looks hard to do is because you can kind of see that we're not really getting that information through here very easily. So if we look at the simulation region, you know, it knows about the world, but it doesn't really know anything else. So it doesn't know like how to get to a world mode, and we may want to keep it that way, right? So maybe I answered my own question there, you know. Maybe it's not worth the extra complication to change where those live. So if we were to go ahead and implement that in here, how would we actually make sure that these got assigned properly? And what you can sort of see is when we do acquire unpacked entity slot, you can see it assigning a new element here, right? And so what probably has to happen is after you fill the unpacked entity, like in here, and we do register, that's probably where we would need it to show up. So when we add the entity in the sim region, right, it's at that point is where we would need it to have its lighting index assigned as necessary. So in here we would need to like assign indices or something like that. And that'd be something that we would just say, all right, there's the world, there's the desk, assign the indices, please. And then like where we actually put it away. I think that's what it would look like. Right? So when this thing comes into the working set, which is down here, we would assign indices to it. When this thing goes out of the working set, they would get removed. And the problem I guess we would have there is when you add an entity. So here's where you create an entity, right? When you create an entity, if it's a light probe, it will not get that value assigned. You know what I mean? I don't know that we actually care about that though, because when you create an entity, you're doing that at world creation time. And so you don't really want to create light probe indices anyway. Light probe indices are things that you really only want to assign as necessary. And we'll probably want that to be a more tightly controlled process that doesn't just happen when you create an entity anyway. That'd be my guess. So if we take a look at assign indices here, and we pass what we need to pass, in here we would say, all right, the light probe index equals something. Now, in here, we want to check to see if it is a light probe in the first place, right? Otherwise, we're not going to do it. And similarly, when we remove the indices, we're going to want to do the same thing. If it's not a light probe, then it doesn't participate in this process at all. And that's the whole point of having the separate chain. Well, and also to be stable. So what we want to do here is assign the light probe. We want to assert that we never blow out our limit. So we want to say here that first free light probe slot is not equal to 0, right? But then assuming that that's okay, we can just go ahead and actually assign it. And then we say that the first free light probe slot is going to be equal to whatever was in that slot. So you can see that popping that off the free list there. So it's saying slot 17, right, is the next one we can use. So we're going to make this one be slot 17, and then we're going to go ahead and pull whatever is in slot 17 into the new one because it's a free list, right? And then we just want to assert that we never ran out our free list because we're trying to make sure that we don't ever really want that to happen, right? We want to make sure we never have so many light probes. It's not possible to create a world with so many light probes in the active area that it blows out our actual backing store, right? Oh, I just got a notification from somebody that says you might want to ban the person spamming Twitch chat. Sure, I can do that. Let me take a look. Not sure what actually happened there. What I would say is I'd encourage people not to use the Twitch chat specifically for this reason. Basically, like it's like there's not a lot of account validation there, and on the Discord at least I have the ability to set things like this person has to have been a Discord member for a while and things like that. If that makes sense. And so like you know, this person who's just like totally sucks and is spamming our Twitch chat, which almost never happens. I have no idea why that happened. But like, I guess what I would say is, yeah, I have very limited ability to deal with that sort of stuff on the Twitch chat because anybody, they don't really try very hard, if that makes sense. But hopefully that person, just looking at it, like they've violated the Twitch terms of service like multiple times, right? So that person should have just been banned from Twitch. That has really nothing to do with our Twitch chat. It's just interesting that people like that exist in the world, right? Human beings, they explore all random possible things. Yeah, and the other thing I would say is for Discord, we can also have there is a subscribers only section already. And if we found that we were getting to the point where we needed to be like locked down or something, we could do that too. Right. So anyway, looks like you guys took care of it though before I got there anyway. Back to what I was doing before we had idiots in the Twitch chat, or idiots singular, I guess. It's been a while since we've had one, like a year or more, I think. If we go on here and take a look at what we're doing with our indices, when we assign indices here, you can see us doing and taking it off the free store. When we remove indices, we need the opposite process, right? So we need to be able to reclaim this value. And so what we would do there is say, all right, let's assert that this is not equal to 0, right? So we basically want to say, if it was a light probe, it should have had a lighting value, and so now we need to remove those indices. That's not true. If it was created, it would have had a 0 value there. That's not actually true. So what we want to do is say, if it has a light probe index, then we want to deal with it, right? Excuse me. So what we want to do there is say, yeah, okay, the light probe index, when we actually go and see that it has something validly assigned to it, we want to give that back to the free store in that case. So we want to say that whatever the first free light probe slot currently is, we want to take the light probe slots themselves, go to the place where this light probe index was, right? And set that equal to this one. So basically chaining on like we would a linked list. And then we say, okay, now we are the next available one to use, the one that we just got rid of. Make sense? Now, unfortunately for us, we kind of do have another nasty problem here. And what that is we don't really have a way of telling the graphics card or the lighting system that we switched out these indices. Right? And that's the part that's really kind of a little bit rough. And we kind of need that to happen. And what I would say is we don't really want it to happen here. Where we want it to actually happen is, for example, in fill unpacked entity, right? You can see this code here. We would probably want it to happen more like in here. So when we actually fill an unpacked entity and we say, all right, if this thing was a light probe, we probably want to send down something that says, hey, this light probe just got initialized. Like, don't use old values for this light probe. And the natural way to do that would be to push something into the lighting solution, but what you can see is we don't actually have that here. And that makes things pretty tricky for us. But what we can do is do something a little bit crappy for now, and just say that our entity has some information in it, right? That says, in addition to the light probe index, we'll also just for now do a light probe clear, okay? And so what we can do here is say, when we fill an unpacked entity, what we can also do is say there's a light probe clear. If this entity's light probe index is set, right? And then that would allow us to clear this one when we actually see it. When we come up to actually do whatever it is we're going to do here, we can also say, like, right. And so what we can do here is just make sure that this stuff is fairly rigorous, and we can just also say that when we see a light probe index, if we also saw a light probe clear, and what we're trying to do here is say, look, we're storing all of the lighting information in a table. You know what I'm saying? Basically, what we want to do is we want to make sure that the lighting information that's in the table doesn't pull some index and say, okay, there's a light probe, it went out of the active set, it had a bright light there, like it was recording a bunch of light that really was there. It goes out of the active set, so we reclaim its index. Now a new light comes into the system and it gets assigned that same index. We don't want it to think that there was that bright lighting there, right? It's a bug to move the lighting from one place to another just because we reused an index. So what we're going to want to do eventually is have a thing that allows us to say, clear the lighting in that slot. Like, I know we've got old information from the previous frame that we blend in. Don't do it. It's like a mask to the blend that knocks it out, right? And so that's just a little something we need to do a little bit later. Okay. So off we go, right? And so on. I love how people are like spamming our Discord now. Unbelievable. Wait, how did someone fix that? That wasn't me. Wow. All right, I don't know. That is super annoying. So we may actually require, if that kind of thing keeps up, then we may actually require people to do some kind of a registration, right? Like, I could do that. It's just very annoying, like I'm trying to program and people are spamming, right? We almost never have that happen. I'm not sure why we had it happen today. That's a good question. Just pathological stuff, I suppose. Fortunately, it's pretty easy for me to see. Like with the Discord over on the side, like it actually works pretty well. Basically, like if Discord is getting spammed, I see a little red number going up. It's harder for me to see if the Twitch chat's being spammed, if that makes sense. So we'll see. But yeah, it's pretty hard to pretty hard to deal with the Twitch chat, and I'm not sure I super care because Twitch doesn't really care themselves. Like Twitch could fix that pretty easily. I mean, just to give a very simple example, like that person literally like typed the N-word into our chat. It would have been pretty obvious for Twitch, you know, this stream is marked all ages. So like if Twitch had any clue, as soon as someone typed in a word that was obviously not acceptable for all ages, that person would just be auto-banned, right? And I don't really know why they don't do stuff like that. If you have a stream that's marked adults and you want to allow free speech on it, that makes perfect sense. So yeah, I mean, at that point you have to have a human who knows whether or not something was allowed. But I don't understand why Twitch still has situations where people are typing words that are obviously not, like, no one would think that that was okay on a stream not marked for adults, right? I'm not sure why you can still have those kind of problems in a Twitch chat. It kind of boggles my mind. Because it's, if you can't air it on primetime television, then it's not okay for, you know, a Twitch channel marked all ages. So that should be simple. I agree that it's more complicated if you want to talk about what adults can say, because adults can kind of say anything they want to. That's sort of how free speech works. But this stream isn't marked adult. I don't say those words on this stream. It's marked adult, right? So I don't understand why a stream for all ages can't have the basic baseline that anyone who types in a word on the stream that you couldn't broadcast over a typical government allowed airwave would be allowed here, right? It doesn't make a lot of sense. It's supposed to be a family-friendly chat. That's different than an all ages chat where you can say whatever you want, right? I don't know, Twitch. You sure don't make it easy on streamers. Anyway, moving on. Like, if we actually go back to what I was trying to do before, you know, Twitch interceded. If we take a look at how we're using, like, how we're using our light probe assignments, what we can see here is light probe wasn't actually something that was callable from inside here. So we're going to have to define that as a thing that you know, operates a little bit broader, and that's fine. Because, you know, lighting is a very integral process. It requires optimizations. I don't mind those things being coupled a little bit more tightly together. So that's actually fine as far as I'm concerned. Now, when we're actually setting up this stuff here and we do a create world, I don't know how many lighting indices I want assigned. And so what I want to do is I want to try and make that be, like, related to how many things we have in the actual game commands. So if we take a look at our game state, right, inside here, we need some way of figuring out when we begin like a render frame or whatever. That's going to tell us how many lighting things we actually can use. I need that information to sort of be provided to me in some way that's convenient, right? Because I need those things to be stable, and I need to pass it down here. I need to, like, say how many indices I want this thing to work with, right? And so in order to do that, what I would need to do is get that information out sooner. Like, I can't wait just until I've created a render group. I need that information to actually be put in sooner. And so if you look in here where we do begin render group, we can do, you see the render commands kind of get passed in, right? So if we look at how we're passing those in more broadly, and I look at, let's say, the world mode, right? or at least I tried to. Did I go the wrong? There we go. What you can see is the render commands get passed through here as part of update and render world, right? And so if we look at where that happens, there it is. We're getting these render commands sent down to us as part of the sort of overall process here. They're getting sent down in game update and render, and if we look at where the render commands actually come from, you can see that they're actually passed inline to this routine, right? And so what we should be able to do in here, where we actually contemplate creating the world, which actually doesn't happen in here, right? It happens in world mode. Yeah, there it is. When we actually contemplate creating the world, that play world call, right? That's something that we actually have to track down and pass something to. So I'm going to bubble it up. Excuse me. Like so. And I'm just going to let the compiler like figure out what the call chain is that we actually need to pass this down through, right? So here is the this check for meta input, right? This is the thing that allows us to actually start playing the game here. And we need to pass that down here. This is a piece of information that this actually needs, right? And so I guess I could look at this two different ways. When we look at check for meta input, it actually does get it passed here. So I'm going to actually just say, all right, render commands gets passed in here. And then we just get it out of here. And now we're actually passing it from the graphics system. So we know that it will at least be somewhat correct. All right. So now I think we're good. And what we would like to do is we'd like to actually go ahead and verify that, you know, we're assigning these things reasonably. What you can see here is it looks like we've got a slight issue here, maybe with something where we didn't clear something, for example. But let's take a look. So if we look here, what we can see is the brain slot type, right, is what would tell us this. If we look at what's going on with the brain ID, you can see that there's no brain ID assigned to this thing. And yet at the same time, it's got a light pro index of 1511, right? And that doesn't seem right. So now we kind of have to figure out, okay, what did we screw up, right? So let's find out. If we go into the Handmade world code and we look at what's going on here, what you can see is we ask if it's a light probe in both cases. So in theory, we should never really be assigning that light probe index in a case where we didn't actually know that it was correct. And so I'm not sure exactly where that information is coming from, but it could be possible that we're doing this at the wrong time or something else is happening, right? What I would like to do is make sure that pack entity doesn't happen anywhere else. Looks like it does. I'm not sure. So looking at that, that makes me wonder if I should have really put this into pack entity. Where else does pack entity occur? Yeah, so maybe that should just happen there. So maybe remove indices should just be inside pack entity. And then assign indices is a kind of trickier one, right? But I think it only wants to happen just where fill in pack entity happens. And so what we could do is just do it in there and pass the world in. I don't know if that's the right idea, but I'm getting sort of an inkling that maybe it is. So maybe that is something that actually only happens there. I'm not sure. But let's go ahead for now and just do it like this. not sure this would really matter, so I'm suspecting it actually won't. But what I'd like to do is just start there, right? And then we'll start debugging. That way I know whenever I pack an entity, it's actually going through the same code path, and it can't go through two different code paths. But what we're seeing here is when we get into one of these things that actually had a light probe index assigned, for some reason the thing is not saying that it's an entity, that's a light probe, and so that's a little bit confusing. And so what I'd like to do is find out why that happened, and more specifically, I'd like to find out if it happens all the time. So like when we come through here, is this like the first time we see this, that it happens? No. So actually, we are assigning light probes somewhat correctly, right? But then what happens is at some point we get a bug, and somebody ends up with one that, you know, maybe shouldn't have had one or something like this, right? All right, so we have to figure out what's going on there. We don't really know. First question I have is, are these things cleared, right? I don't remember what our rule was for how entities start out. So when we create the world, do we clear that buffer? And I don't actually know. I suspect it's true. Looks like it's true. So when we're actually looking, Jimmy, when we're actually looking there at unpacked entities, it looks like that should roughly be working properly. So I'm not 100% sure why would we ever getting a case where the light probe index was assigned to something, but it wasn't a light probe, because it means that someone had to have moved around or done something, or I don't really know. They had to do something squinky, because in general, we only ever enter things that have to do with the light probe index. We only ever do anything with those when we already have determined that this thing is, in fact, a light probe. So in pack entity, we only actually look at that value and clear it to 0 if it's a light probe. What I could do here is say, you know what, assert, in this case, that the light probe index equals 0. That gives us one more layer of checking in one more place that might catch bugs. Excuse me. But then in the other case where we're actually doing our fill unpacked entity here, and we then go to do assign indices, in that case, right, the assign indices call also only does it here, right? And we should always assert, no matter what, that the entity that we're getting should have a light probe index of 0 at that time. And so I think that's all good. In fact, this assertion should just happen here, meaning by the time you're out of this case, no matter what happens, the light probe index should be 0, right? That should just be a given. So there's a few more asserts. I don't think those will help. I think we've got some other bug. Oh, no, they did. That's great. So here you can see us assigning an index to somebody, but for some reason the light probe index is already non-zero, and that should never actually happen. And so that creates an interesting question of why is that happening? Like, how did we get into that position, right? So let's think about that. Let's think about why that's actually happening. Because we should have had a call to pack entity there or something that should have actually removed this entity from the system, right? And if we do clear unpacked entity cache, I don't know if that ever gets called. Yeah, that gets called when we finish the world entirely, right? But when we call it clear unpacked entity cache, we go through every entity that exists in the system, and we pack them all. So at the end of that, every single entity in the entire system, all of them, right, should have been packed and therefore should have had their information cleared, right? That should have happened. So if I do an assertion here and say light probe index equals 0, now if I run, I should end up in a situation where I know that everything started out that way at least, right? So if we take a look at what's happening to this entity now, and I see like, well, what light probe index does this thing have apparently? And it's got light probe clear set to 1 as well. So what's going on here? Why are we assigning an index sign that looks like it already had an index assigned? Are we calling assign indices too frequently, you know? I guess, I don't really know, right? But if I look through here and I go and I'm saying we're unpacking a world chunk in here, I acquire a new slot and I copy in the entity data, right? The packed entity data. That shouldn't touch those later values. I then do a fill and assign indices and I register the entity. That should be it, right? So I'm not really sure what's going on with that particular bug. I'm tempted to end it there because this debugging could take a while. This is a bookkeeping sort of thing, right? And I don't really know exactly where my bookkeeping bug is. So we may want to just call it a day and start tomorrow on this particular bug, right? If I can think of one other place I want to check. So one question would be deleted. If an entity gets deleted, that's a good argument for why it can't be in pack entity, right? Because there's two separate paths that happen there. So in here, we really do need this part. And these both do actually want to be called very discreetly, like very delicately, right? And so what we want to do here is say inside pack entity, if we're going to pack the entity, then we know we need to remove the indices. That's definitely true, right? So when we come in here, we just have to say, all right, remove the indices from this entity. But in the case where somebody got deleted, we also want to do that, right? And so it's going to do this path, but not this path in here. So we do need two places where assign indices happen, sort of, or rather, one place where assign indices happen, and two places where remove indices happen. Really three, because pack entity gets called in two places. And it's fairly complicated, right? I don't think that's actually going to solve the problem necessarily, but it was a problem. So at least we got that one out of the way. All right. Because I don't think we're deleting any entities right now. That's why I don't think that's really relevant. So that's the situation. If we look at what kind of a brain slot type this thing had here, it's just a 0 entity. So I'm not sure, again, like why it was getting this assigned indices happening. I should double check if I set a breakpoint there. How often does this get called? So it gets called on every entity when it gets unpacked, as I would expect, right? In here. It's kind of interesting that that's going backwards down the ID stream, but there you go. I guess that's what you'd expect. This is in the clear probably, right? Oh, no, it's just removing them. Here we are assigning new indices. Again, during the unpack. So we've actually done quite a bit of reassignment here, right? For things that are probed. So yeah, I couldn't tell you. I'm not sure why that's... There must be something subtle about the way that this code was working. I'm not sure. So I think that's going to take a while to debug. So I'm going to go ahead and say, let's just take care of that kind of a little bit further down the road. So I'm gonna save that as a thing for next time. For now, let me go ahead and see what we've got for questions. And again, you can go ahead and use hashtag live on the Discord. Any questions? Other than why are internet companies so bad at preventing tons of spamming? All right, looks like no questions. That keeps it simple. All right, we will debug that tomorrow, and then we will move on to actually drawing the lighting, because then we will have stuff to submit. And that'll be our first, that will be our sort of first foray into the lighting. Off topic, how do you parallelize hash functions? You use a Merkle tree. I mean, you can't parallelize a hash function, right? The point of a hash function is that it is not parallelizable. And so what you have to do is you have to hash your hashes, and usually a Merkle tree is how that's done. Just so if you take a look here, this is just the basic idea. You want to hash all this, and you need to parallelize it. You can't get a hash of all the data, because the whole point of a hash is that the hash depends on all of the data and the order in which the data came. And so you can't really run the same hash function parallel, because it needs to update its state always. So what you do instead is you break it into blocks, you hash the blocks, and then once you have the hash of blocks, you hash those together, right? And you can imagine doing this in a hierarchical fashion, so that each time when you hash things, you then hash the hashes and hash the hashes of the hashes and the hashes of the hashes of the hashes, right? And if your hash function itself is good and has certain properties that you would want, then, cryptographer people have done the work to prove that the Merkle tree can only be so bad. On top of that, meaning the amount of hash quality that you lose from employing a Merkle tree is not arbitrary. It's basically something that actually, we know. It's also worth noting that it was patented in 1979, which means that if you use a Merkle tree, you have the nice benefit of not being able to be sued for patent infringement, because the patent has expired. Right? So if someone comes to you and is like, you're violating this cryptography, you're like, no, I'm not. I'm using the 1979 algorithm by Ralph Merkle, which is in this patent, which has expired. Thank you. Right? So that helps. Some cryptography things are still like patent unsure, right? And so sometimes it's nice to have something In the old days, that was patented because then you can just go back and go, well, that's the algorithm, and so I can't be liable because I'm using it, and it's expired. There we go. So anyway, that's what you normally do. A miracle tree is how you would normally parallelize a hash. There's other things maybe you might want to know about, but that was the most common thing, right? All right, two more questions. How is the hash function like the meow hash useful for game development? The way we typically use it is for asset tracking. So the way that meow hash is employed typically, or other functions like it, is that you want to know when like files or intermediate outputs are the same. So you've got like terabytes and terabytes of assets for your game, right? In a big AAA game or something. And you're trying to do stuff like fingerprint those assets and also intermediate versions of those assets, so you know when they need to be rebuilt or when they have changed, right? So they're used for signatures on things like assets, typically. Piston Miner asks, this is sort of off topic, so if you don't think it's relevant, feel free to disregard. With member functions, they're namespaced based on the type, whereas the free functions are all in the same namespace unless you specify a namespace, of course, what the compiler generates is identical. Since you don't use explicit C++ namespaces as far as I know, do you think this is a problem? And if so, how do you work around it? No, I don't think it's a problem. And you can, I mean, Handmade Hero, I don't even want to know how many functions we have, but we've got a lot of them and we've never had a problem with it. So it's just not a problem. I guess you have missed most of the last few streams. Could you run the game quickly, see where we're at? We run it today. Just take a look back at the VOD. We've run it a bunch today. We ran it at the beginning of today's VOD, in fact. Regarding the chat in the Discord, the reason we don't have a subscriber-only chat is because, yeah, like people don't necessarily subscribe on Twitch. Sometimes they buy the game, and I don't necessarily want to encourage people specifically to subscribe on Twitch, right? In terms of followers-only chat, I don't know if Twitch has such a thing as a followers-only chat. But even if they did, I'm not sure what that would do, because anyone can just follow you for free and then unfollow you. So if they wanted to spam, they'd just spam you a bunch and then unfollow, right? So I don't think that would actually help cut down on the spam. It might be good for people who want to boost their follower numbers, right? Because, hey, then that would force anyone who ever wanted to type in the chat to follow the stream or something. But I don't know that it would actually help you with spammers, because why wouldn't the spammer just follow your channel and then spam you, right? They don't care. So I don't think that really would help. Subscriber only would definitely help cut down on spam. But then again, yeah, like that might be too restrictive because a lot of people probably don't subscribe on Twitch. I could force them to subscribe on Twitch, but, you know, I don't know that that's really that necessary. And, you know, Twitch doesn't give us that much money. Like, I'd much rather you bought the game than subscribed on Twitch, because Twitch only gives us like half of the subscriber value, whereas the game, we get the whole thing, right? So it's like not even in our best interest to try to convince you to subscribe. I put it on there mostly just because then we get all the extra benefits from Twitch. Like if you have a stream that is a partner channel, you get a bunch of better services, right? But yeah, I don't even, does Twitch even allow follower-only chat? I know they allow subscriber-only chat, but... Since we're going off topic, I was looking at DPI aware UI and rendering. It seems annoying in Win32. I'm usually many years behind trends, so is high DPI rendering a thing to worry about these days? Yes, it's definitely a thing to worry about, and no, Windows never fixed it. I don't know what goes on over there at Microsoft these days. I kind of get the impression it's like a bunch of like babies running around a ball pit at like, you know, a McDonald's playground or something. So they've like updated the high DPI API calls like multiple times, and they're wrong every time. They've gone through like 6 in the span of like 5 years, and they're all wrong still, totally busted. And so I just don't even know what to say about it. It's a disaster. I mean, anything that's modern is kind of a disaster because Microsoft just doesn't even know how to make functional APIs at all anymore. It's completely over. And so it's a disaster. It's an absolute unmitigated disaster. All right. On that depressing note, I'm going to go ahead and close things down. Thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code so you can play around with it at home and build it yourself. Maybe you can go find out what that bug was today before I have a chance to come back and debug it tomorrow. That'd be a good exercise, right? I will be back here tomorrow, same time, same place, and we will fix that bug. Hope to see you back here for that. Until then, have fun programming, everyone, and I will see you on the internet. Take it easy, everybody.